Fire, embers, and heat, working in a steel forge is truly backbreaking work. Even in the age of high technology, blacksmiths perform heavy physical labor. At this facility, gigantic generator shafts weighing 80 tons are cast and forged. With massive gripping tongs, clamping and hammering take place. Let us have a glimpse into the inferno. This facility specializes in shafts for generators and turbines. Final preparations before the descent. The molten steel in the electric melting furnace is now above 1,700 degrees Celsius. Tons of the glowing mass shoot into the ladle. The exact alloy composition is a secret. From the ladle, the molten steel flows into the mold. After cooling, the ingot is placed in the so-called hearth furnace. These gigantic furnaces consume as much heating gas per day as a small town. If such a glowing block slips from the crane grippers, it causes massive damage. Accordingly, the crane operator works very carefully. This plant has the most modern freeform forge in the world. The jaws of the gripper and the crane chain can move workpieces weighing up to 165 tons. Shielded from heat and noise, the operator and crane driver sit in the control cabin. Here are the forging steps for the large generator shaft. The work process spans an entire week. Initially, the press forms a projection that allows better gripping. Carefully balanced, the chain crane rotates the glowing ingot. The blacksmith controls the so-called manipulator via a joystick. A massive chain assists with turning and movement. First operation, stretching. The press elongates the ingot. Under gas pressure, slag springs off the glowing block. Using compressed air, the worker blows off the residues from the so-called forging saddle. Forging densifies the internal structure of the steel, comparable to kneading dough. The workpiece must not become too long, therefore, the forging team constantly checks the length. The block is no longer hot enough for further forging and returns to the furnace. The slag must be removed from the work area. The press heads or saddles are now being replaced. Between these saddles, the workpiece is pressed and elongated. Forging and reheating, this sequence repeats several times. This densifies the steel and is essential for shaft quality. After half a day in the furnace, the crane retrieves the massive workpiece. The next operation is upsetting. The crane places the block vertically. The press compresses the glowing metal centimeter by centimeter. The block is now compacted and laid horizontally again. Meanwhile, the team prepares tools for the second stretching. Thousands of tons of pressure shape the workpiece into the desired form. Production enters a critical phase. The chain crane must secure and support the glowing mass. Blacksmith and crane operator work as a coordinated team. Often, the manipulator alone is insufficient. The forging crane is required to keep the shaft straight. Otherwise, the workpiece may bend. The workpiece is still not finished. The ends contain so-called head and foot scrap. These pieces are cut and returned to the melting furnace. The shaft is going through a heat treatment cycle, where it is reheated. Then an important step follows. It is quenching in a water bath. The last heating and quenching give the shaft the required mechanical properties. The shaft is 13 meters long and weighs more than 80 tons, and must be submerged in a huge tank. After that, surface machining removes up to 14 centimeters of steel to achieve the required dimension and shape accuracy. This machine works with half-millimeter precision. The plant manufactures more than 200 shafts per year. They are used for power plants and ocean liner generators. A testament to precision engineering, teamwork, and innovation, transforming raw steel into generator shafts that power the world. Manufacturing technology is a versatile knowledge area, so don't miss the next video to learn more. And if you found this lesson useful, please like, share, and subscribe for more manufacturing videos. Goodbye.